Hey everybody, this is Larry. This is me going Q4 of the bi-weekly contest 145. Count connected components in LCM graph. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. So honestly, this one I honestly implemented it pretty quickly, but I didn't know how to do it immediately. Whether it is because I just woke up or whatever, I definitely struggled a bit with understanding what LCM and how it deals with, right? And this is also, I want to point out the importance of practice, right? If you practice enough, you'll probably see LCM enough that you know some properties that you can play around with. And honestly, I did it in about 14 minutes. We'll go over the code real quick, but honestly, during the contest, the virtual contest as it was, I did it YOLO. And what I mean by that is just that I knew that I was missing a proof, but I was taking a risk on, well, if I was right, then I'm right? Yes. But if I was wrong, then it would give me an input that hopefully clarified my position, right? So that's basically the idea. The first thing though is always look at the constraints. And here, this problem is very weird in this sense, right? Because I think the most important part of the problem is actually all the way at the bottom. N is 10 to the 5th. I mean, that one I actually probably would have assumed for Q4. That otherwise, if you're able to do N squared, it is not an interesting problem and it would not be a Q4. Unless I misread it, of course, which happens sometimes. The second part is that each number could be 10 to the 9. Then I was like, oh, okay, it is pretty big, so maybe we're looking for a general solution. The next part is that, and I'm doing this one at a time for a reason you'll see, nums are unique. Okay, the nums are unique, that's fine. Actually, this one doesn't change anything that much, because if they're not unique, then you could very trivially merge itself, right? Kind of. I mean, because it depends on the threshold, so if two numbers, if either of the numbers is bigger than threshold, then even if they're the same, then, you know, so you could special case it, but either way, they made it unique so you don't have to. The next, though, the one that I found most interesting when I first saw it, I did a double take. I go, double take, threshold. And threshold only goes to 10 to the 5th. And that was kind of like, okay, well, my first thought immediately is how do I abuse this? And knowing that, well, there are two things, right? One is kind of what I already talked about a little bit hint at, a little bit of a foreshadowing, if you will, is that, well, with not even two numbers, but if one number is bigger than the threshold, well, the LCM of that and any other number is not going to be under. So they're going to be in its own connected components no matter what. So you can filter those out. But what that means is that if you filter all the numbers by threshold, what does that mean, right? Well, that means that you're left with numbers that are less than or equal to threshold. So that's basically the first part. And now that I know that to be true, what can we do? Well, we can do a SIF type thing. And this is the part where I did not have a proof for during the virtual contest. We'll go over the code. Let me kind of rephrase this. The way that I thought about it would not, like the way to do it without the proof, which we'll talk about when I go over the code, is computationally expensive. It might not be fast enough, is what I was going to say. But to make it computationally fast enough, I rely on a proof that I did not spend time to provide, honestly. Like, not to say that I couldn't do it, I just didn't spend time to look for it. And that's basically the idea. So we'll go over what I mean when we look up the code. So the first of all here, this part of the code just filters out all the numbers that are bigger than threshold. And of course, if the number is bigger than threshold already, then we already, it's its own connected component. So I named it total, but maybe I'll just write like filtered component or something like this, right? So maybe that's a more descriptive name, and I'll write bottom, and you know, let me just run it real quick to make sure that I didn't have another typo. So that's basically the idea. The second part is of this code, right? I don't think I need to sort, but I don't think strictly speaking I needed to sort, but sorting is roughly free, more or less, unless you do it too many times. So I just sort to kind of give a structure, and it just makes more sense to kind of do it from a small to big kind of thing. Maybe I don't think that's necessarily true actually, but that's how I thought about it. Yeah, and this part is just very standard union find. Not gonna go over it here. Again, for Q4, if you want to have a chance to solve Q4, union find has to be a strong part of your toolkit, right? Like you have to be good enough at it. So I'm not gonna go over it for this video. It's okay if you pause this video, learn about union find. There's so many videos on union find on YouTube. Not me, because there are 1,000 videos on this, maybe even more actually. Why am I doing 1,001st video, right? So I don't usually make videos about elementary algorithms that you can find in a textbook, right? But in any case, yeah, so you can find union find. I'm not going to go over the idea and complexity here, but let's just pretend for a second that it basically gives us, like if you're not familiar with it, we'll use it as a black box, which is that you have two functions. You have a union, which connects, you have two connected components, A and B, you connect them into one component. And then you find is just, okay, well, you have a node and you try to figure out which component it belongs to. So that's basically the idea. And without too much proof and maths, both of these, let's just say, is O of 1. I know there's some nuance if you actually know union find, but let's just say that for now, right? Trust. But yeah, but other than that, then here is what I call the SIF. It's not quite the SIF in the same way, but it is relatively, it is the SIF in the sense that, like it's not the prime SIF, I guess is what I mean, but it's another SIF. But as a result of you doing the same logic as a SIF, the key part is that if you do this in the naive or the standard-ish way, say, then this is going to be O of t log t, where t is the largest number. In this case, it is the threshold, right? And yeah, and basically I have a previous thing, which is actually not a thing, but previous, I didn't want to think about a name during contest, but just the smallest factor of x, right? Smallest, I guess, yeah, smallest factor of x. And what you do in this case is just you have a number x. If there's no smallest factor, you set it to x. Otherwise, you just go through the entire list, right? You go j, or you go x, 2 times x, 3 times x, ... and you count all the way up. And what that does is that in the future, when another number hits your number, it would union them, right? So that's basically what we have here. For example, you have let's say you have two numbers, you have 2 and 4, right? Let's try another one. Let's say you have 2 and 3, right? Well, what's going to happen is that 2 will fill 2, 4, 6, 8, 10, 12, 14, ... right? And 3 is going to fill, well, it's going to fill out 3, and then when it gets to 6, it goes, oh, 6 is already filled with the number 2. So that means that we want to merge them together into one component. And that's basically the idea. And the other invariant, of course, is that both x and j are always under the threshold. And therefore, previous of j is also under the threshold. So that everything inside keeps the invariant that everything is under the threshold. Okay, so we know that this is going to be t log t. So the question that I actually was, okay, let me finish this part because it's just really short more, which is that, okay, afterwards, then now for each number, we figure out what component it belongs to, and then we add it to a set to dedupe. There are also other ways to do this. For example, you can make union, you can make the union return whether it actually unioned. If it unioned, then that means that, yeah, if it union, that means that you merge two different components, which means that you subtract one connected component. But either way is fine because this is linear, right? So because this is O of 1, as we say, this is O of n, so this is going to be O of n, and that's pretty much it, right? So what happens right here, right? Well, there's an n log n here, I suppose, but I don't even think it's necessary. This is O of n. This is all O of 1 per operation, which so you could effectively forget about it. I know for, just bear with me anyway. But yeah, so it's going to be dominated by this t log t. Yeah, t log t, right? So, okay, so let's say we have t log t operation, complexity, sorry. We're happy, right? Then what was Larry talking about? Well, one is that you need to prove, because the idea that I had was that, okay, well, let's say you have 2, 4, and 6 as your input, right? Then, well, then almost feels like in that case the order matters, right? And this is where we have the transitive property, but it does not hold, right? Because LCM of 2 and 4 is going to be 4, LCM of 2 and 6 is going to be 6, but LCM of 4 and 6 is actually 12, right? So so as you can see, there's no transitive property here, right? So it's very awkward, because then now, how do you know that, let's say we combine 2 and so then now, how do you make sure that, like the ordering doesn't matter and all these things, right? Because if you combine, say, 4 and 6 first, and then, because the way that we structured it, and maybe the sorting helps, right? This is where I always like, okay, sorting might not help, it definitely doesn't hurt, so I just add it in. But let's say you have this case and you don't sort it, right? And you do this first, and then as a result, when you get to maybe this is a little bit of a wrong example in any case, but let's say you do this one first, you go, it doesn't merge, but then you only do this, and then maybe as a result you skip the 2 to the 6 because you thought, maybe you even skip the 2 to the 4 because you do like if you try to parse this in this order, 6, 4, 2 or something like this, and you wrote the code in this, not the way that I wrote it, but in a weird way, then or 6 to 4 maybe, right? So then now we do 4. Actually, I guess what I mean is 4, maybe 4, 6, 2. I don't know. But in some order where you do the 4, 6, and you go no good, and then you go 2 and 4. Okay, that's good. But then you skipped 2 to the 6 because you assume that you already did it because of transitive property, right? So as a result, so as a result, this is the proof that, like, if you wanted to be correct with our proof, then what happens is that here, you actually have to store all the numbers, right? And what I mean by that is that instead of, here we only store one number, which is the smallest factor, but what we might have to actually do is to store all the factors, right? Like you have to store both in here. Maybe you have to store like 2 and 4 and 6. So then here, this becomes a for loop, and then it becomes too slow. So that's the key part about this problem. But it turns out that the way to think about it, the way that I thought about it after the contest, after I already submitted it and YOLO'd it, is that, okay, let's say you have A less than B is less than C, right? Without loss of generality, because you could just sort them like I did. Then now, I think if LCA of B is less than or equal to threshold, right? And LCA of B and C is less than or equal to threshold, then actually it implies that A to C is less than or equal to threshold, right? So it turns out that while you cannot say that LCA and B is I don't know how I'm saying, but the way that I would think about it is that, so while the transitive property doesn't hold in that case, in the initial case, but once you make this into a Boolean almost of, well, if this is under the threshold and this is under the threshold and this is under the threshold, then now you can reduce this to just caring about the smallest factor, which is the proof that you need. And here I'm not going to go over the proof, but I feel like it's also a easy proof now, I think, if you understand LCM. So, but because this holds, I believe that, this was fast enough, and that's what I was YOLOing on. And that's pretty much it. So this whole operation this whole code is dominated by this part in terms of complexity. So it's going to be all of T log T time and all of T space. And that's all I have for this. Well, technically, all of T plus N for this thing, actually, I suppose. Okay, I think that's right. Even though they're unique values, so T is always going to be bigger than N for that reason, right? Because they're unique, but, whatever. Yeah, that's all I have for this one. I'm going to show the top of the code. This is the filtering code. This is the union find. I guess there's also the sorting. And if you watch the live portion, I type all of this live. There's no template, no nothing. Yeah. Did I even Google anything? No, I don't. I Googled anything. I was just being dumb. But yeah. And then here it is. A smallest factor shift or something, if you want to call it that. And that's pretty much it. And that's all I have for this one. Let me know what you think. Thanks for watching, and feel free to ask questions because this is not an easy one. And yeah, and you can watch me solve it live in the contest next. I don't think that's clear at any time that that's wrong answer. That's kind of a crap problem, or like a crap edge case anyway. I mean, maybe that's the problem is fine actually. Okay, let's see. 3378 count connected components. Let's see. Okay, slow down. Okay, so you have integers of size n. There's a graph of n nodes. 2 nodes I and j on the graph are connected with undirected edge. Let me reread this. I'm still tilted a little bit from Q3, so I'm not reading it. Okay, so the n nodes, the ith node has the value of num sub I. Okay. Okay, and then 2 nodes I and j are connected if the least common multiple is less than or equal to threshold. Return the number connected. Okay. I assume n is big enough that you can't just do like an n square thing, because that's just silly. Threshold is some big number. What am I doing here? How much time do I even have? Oh, I have an hour. I probably could do this, right? An hour is a long time, even though we wasted a lot of time on Q3 because writing comprehension is, or writing skill is a little bit weak. How would I think about this? Is there a transitive property? So we have 2 and is there a transitive property? I think the first thing I want to do is sort, right? I mean, if they're all relative prime, not relatively prime, but if they're all under the threshold, my idea is going to be n squared, so that's not going to be good. So no. So how do you do it? So okay, you take the smallest number. Does that help at all? What does LCM mean to me? What does LCM mean to me? I mean, there's like a minor filter with threshold and the numbers, but that doesn't even matter, right? Or like it's not the worst case because threshold could... Oh, threshold is much smaller. What does threshold mean? Why is threshold small? Threshold is small. All numbers are unique. Okay, that's another thing actually. Is that even mentioned? Maybe it is, but it's just hard. Like it doesn't seem like it's mentioned here actually, and that's kind of crappy. That, you know, it's like, hey, here's the actual problem. What you read is wrong, or what you think you read is incomplete. Okay. All elements of nums are unique. The threshold is small, so actually I was lying about the nums not being matter because of the threshold. Everything bigger than it gets filtered out, so then you can maybe do some like sift-like thing, right? Sift-like thing. How do you do a sift? You do a sift by Is there an LCM SIF? Well, if one number is multiple of the other, then So if you do a SIF LCM, you go up to the threshold, you just look at the parent, or like you only have to merge with one other number because of, is that true? Can you get stuck? And I proved that I only need to merge with one other number. Does that complete the chain? Is the smallest number that gets to that multiple the only thing that matters, or do I have to look at all the other ones? I don't know, but I'm gonna YOLO because I feel like it feels, I don't know. I mean, I feel like it is in the ballpark of the right answer, that if I get it wrong, I get a wrong answer that will enable me to solve it, maybe. Hoping for it anyway. Okay, so then now we have, so actually I lied about this part. What I want is, I don't know, whatever, something like this, right? So for x in nums, if x is greater than threshold 1, right? And then maybe just like, I don't know, yeah. I could write a one-liner, but I guess I'm just, yeah. Okay, right. I don't even think I need sorting then in that case, right? And then now I do another SIF of whatever, smallest whatever. There's like a name for it, but whatever. Threshold, right? And then now maybe I still want to sort. I think maybe it matters. I don't think it matters that much, but maybe it helps, right? So then now for x in nums, and they're all unique anyway, right? So if previous of x is none, then previous of x is equal to x. And then while x is less than or equal to threshold, we do something like x increment. Oh, now Larry, you already forgot how to write. You already forgot how to write SIF, the same code you win 10 minutes ago. I did forget. Right, something like this, right? And then we need a connected components part, because basically if previous of j is not none, then we want to union j and we want to union previous of j and x. There you go. Right, and then maybe if this, we increment a count or something. Okay, but then now we have to read the union code. So then parents is we need one for each. What do we need it for? We need one for the number, not the thing. So okay, let's keep it or something like that, right? Maybe. I don't remember how to write it anymore. And then we want to return something of this one. UA is equal to of A, UB is equal to find of B. If UA is not equal to UB, then parents of UA is equal to UB, and then return true. Yeah, it doesn't make sense to return false. So okay, so this is the number of merges. Okay. We have something like Okay, we already have n, so then the number of merges is going to be return n minus count. I think that's it, right? Plus total for the pre-filter, and maybe we're mostly done. Okay, I mean, other than that, it's mostly done. You find, I found. Did I spell it well? Missing one requirement. Do I not usually write it this way? Huh, okay. Is that the, then that's just wrong, right? But okay, yeah. What I actually want then is, I thought I could do it that way. Maybe I'm thinking of someone else. Okay, whatever, then we'll just rewrite it. If x not in parents, or right? Key error is 2. Equal to x 5. That's not right. Ideally, the 2 should merge with 4, right? Is that the thing? Right? Oh, it's because of this thing, I think. Because it, by definition, it wouldn't make sense. Okay, still wrong. What am I doing? So print. It should, if anything, I think I should be wrong the other way, so we'll see. Two. Okay, well, you're just being dumb then, Larry. I mean, it's fine. It's just that it should not be count, but maybe we don't even need this count. We can just count the number of components later. Yeah, okay, fine. I don't know. I'm being dumb today anyway, so maybe I just need to dumb it down so to match my dumbness today. Then what I would say is that for x and nums, yeah. Okay, and then now we have s plus total for the number of components, right? Okay, s plus total is not a number because s is a set, Larry. I'm just not really thinking today. 5, 4, still wrong. Dong. Still adding the same. I mean, that's fine though, right? Why does that return true though? For 2 and 2. Huh? I can't even get union find right today. I guess it was good that I did not. So this returns false. Oh, it's not an if statement. Okay, that's fine, I guess. Actually, I changed. I don't know how to write code anymore today. So we don't merge anything. But why doesn't the 4 merge the 2? Oh, because of this thing. You want to say if pre is not none, then do this, right? Or is none, whoops. And then now we do this loop. Oh, and also, I guess this is fine because we already union it, maybe. But 4 and 2, can I prove this? I will not be surprised if this was incorrect because I don't know that this makes sense enough to me. But it's a YOLO submit. And if it times out, then I'll just be sad. But I can prove that, like, there is some like weird transitive property that needs to be true for this to be true, but I didn't prove the transitive property, so I can. This is just a little bit YOLO. But you know, it was Gucci. Would have finished 70. Wow, even with the silly mistake, I would have finished 72nd. I don't know if that is good or bad, but I mean, it's good enough, honestly. And this is the final, right? Because the Leetcode leaderboard, it's not like it doesn't get updated as it happens anymore. I spent the longest time on Q3 actually. What was Q3 again? Oh, this one. And then and this is like the dumbest problem too. I just wasn't. I just wasn't sure about deleting zero because they don't mention it, and I had to like implement it to do it, and I probably could have implemented this a little bit cleaner, but I was just a little bit lazy. So Q3 was the longest, which is actually funny. Q4 was all YOLO though. I mean, I thought that maybe there's I don't know, 30 to 40% chance that it would be wrong in some edge case, and I have to do some modification to like this part or something like that, where I have to be a little bit smarter and then prove. I think I would have had to prove something to make almost like if transitive property didn't hold, then I would have to make a proof on some other thing that makes it so that we can reduce the factor, but otherwise it becomes a sieve. But I think that's also like a little bit weird, honestly, because we have to do the prime sieve twice for this problem, or maybe not the prime. Yeah, I mean it's relatively like the prime sieve, so it's a little bit awkward, honestly. But I don't know. I guess that would have been okay. And Q1 was just impossible to read. I don't know. But yeah, I mean, this was all YOLO though. I don't know that I can even explain it quite well yet. Can I prove transitive property? I suppose. I guess I could just Google it at this point. Is LCM transitive? Associative property of LCM. No, yeah, LCM is not transitive. What is an example? Actually, 2, 4, and 6. A and B is 4. 2, 4, and 6 makes sense. How do I prove this one? Because the thing is that we have a 6, right? And you match the... I guess technically this always match the smallest number, so it gives you the smallest thing. So, okay, so it's not... So maybe you don't need the transitive property, but with A... So maybe the property that it has to be true is that for A is less than B is less than C, LCM of AB is less than or equal to the threshold, and LCM of BC is less than the threshold, then by definition LCM AC is going to be less than or equal to the threshold, right? So in that sense, you don't need B. So it is a transitive property, but not in the naive LCM sense, I think. Maybe that's the property that I needed to prove, which I think makes more sense on an intuitive or mathematical intuitive level. I know that intuitive is such a hand-wavy thing of like, oh, I'm so smart, it's intuitive to me. It's even I don't have to prove it. But I think this makes more sense than the LCM transitive or transitivity, and I think that kind of allows this thing to be true. Okay, I could buy that. Alright, that's all I have for this contest. Actually, honestly, did pretty okay. 5 minutes is insane, actually. Does that work? Why am I able to click this during a virtual contest? I mean, I know obviously you're just cheating yourself in a way, but like, why is that being able to? Also, this is ChatGPT, isn't it? 2 minutes for 5 minutes. I mean, it's in Chinese, but there's still comments, so it's just but the code looks pretty similar to mine, so I guess that's fine. Actually, even this part is very similar to mine. It's almost like I cheated off them. Oh no, they did the divisor thing instead of the... I guess that could work. I guess you didn't need to do it the Civ way. I mean, I did it the Civ way because we just did a Civ problem. But anyway, thank you, ChatGPT. You know. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, this problem, this explanation, everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.